Alright, this lesson is a new factoring technique. It's a pretty important one going into when you get into Algebra 2 especially. It's called difference of squares, 8.8.
Did you ever look at 8.7 practice sheet?
No. Did I give you guys a grade for it yet? Alright, the way this works, factoring by difference of squares. This only works a specific way. You have a binomial. You have two terms. Since you have a binomial, that was kind of dumb of me to say. You have a binomial. And each one of those terms is something that's being squared. In between the two terms of the binomial, you have a subtraction sign. Hence the amazing title, Difference of Squares. Ta-da! The way it factors is you have something being squared minus something else being squared. So for example, a squared minus b squared is a plus b, a minus b. So examples, a couple of them. X squared minus 25 factors x plus 5, x minus 5. Or you could do x minus 5x plus 5. Once again, doesn't matter the order of the binomials themselves. Second example, t squared minus 64 goes t plus 8t minus 8. Or t minus 8t plus 8. Either way. And how can you check yourself? Why does these work this way? Starts with an F. They FOIL. They FOIL back. Okay, see how these two, t plus 8t minus 8 FOILs back to t squared minus 64? Okay, if you do it, t times t gives you t squared, yay. Negative 8t, positive 8t, those two terms what? Cancel. And then 8 times negative 8 gives you negative 64. You are, but you got to make sure that your signs are right. So honestly, I wouldn't. Okay. So 121 is something being squared. 4 is something being squared, and b squared is something being squared. All right. What's something being squared under 121? 11. Let's go a different color. Minus. What about 4b squared? 2 and b. So 11 minus 2b. 11 plus 2b. Done. Uh-huh. Next one. What is it? 4x minus 3y, and then no, gotcha. So down here, 27g cubed minus 3g. What's being squared in the other one?
3.
No. Nope. Nope.
Nothing.
Not that you can see, right? But what do you notice between 27 and 3? 3 is a factor of 27, which means we can... Nope, not an equation. We can... factor it out. And not just 3, we can also factor out a g. So you have 3g, parentheses, 9g squared minus 1. Now what? What do you see?
3 goes into that. Oh, that 3 is a factor of 1. Like 3 times times C equals 9.
Okay, what does that mean? Good. See how this is the binomial now? This difference of squares factorable? Did everybody catch that?
Yeah.
So factor it by difference of squares. What happens to this 3g? What's he doing?
Goes down.
Yeah, he comes with you. He tags along like that fifth wheel and it's double date, remember? So 3g. Parentheses. 3g minus 1. 3g plus 1. If something factors the second time, you must factor it. Alright. Alright, the first one. 81 minus c squared.
9 minus 4C. This is divided by 1C.
That's fine. 9 minus c, 9 plus c. Good. Okay, going to the right now. 64g squared minus h squared. 8g minus h. 8g plus h. Good. Okay. The third one, bottom left. First thing you need to do is factor out an x. Good. Which leaves you with 9x squared minus 4. X tags along. Goes to 3x minus 2. 3x plus 2. Okay. Number 4, 4y squared plus 9. How's it factor? I wasn't very confident, Dylan.
2y plus 3 and 2y divided is 3.
If that's the case, it should be able to what? It should be able to FOIL back. So what's 2y times 2y?
4y squared.
That's great. What's 3 times negative 3? Negative 9.
Oh.
It's a plus. Cammy. Okay. So that's not it. Other ideas?
2y plus 3 and
2y plus 3, 2y plus 3. Okay. When you FOIL, 2y times 2y, 4y squared, great. 3 times 3 gives you 9, great, but what I'd miss? The O and the I. What's 2y times 3? 6y. What's 2y times 3? 6y. What's 6y plus 6y? Does that FOIL back to this? No. Nope.
9 and 1.
Huh? Well, not that sense, no. Because that's the answer to an equation, there's no solution. The word you want to use is prime. Okay, it's prime. There's no such thing as sum of squares. See how 4 is being squared, y is being squared, 9 is being squared? That's all good, but in order to factor it, there needs to be a minus in the middle. Here there's a plus. You cannot do it. There is no way to finagle your numbers and signs in such a way that FOILs back to 4y squared plus 9. Not possible. Okay? So if you see that, and I'll be a jerk and throw them in there, you put prime. And trust me, it'll be like one of the last ones. So that way you're getting in that difference of squares mode. You're just knocking them out. Pow, pow, pow. And then there's that one. And you know what people will do? They'll just put it and not even ignore the sign in the middle. They'll just boom, 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 and skip right over the fact that it's a plus. See it happen every year. Your speedsters are usually the ones that do it. Okay. Everybody good?
So no matter what, if you see a positive,
If it's two squares and a plus, it's prime. Okay. Now, just because, here's the thing, just because it doesn't necessarily have to be just one x that's being squared. Alright? It could be different things. It could be multiple different things. Okay, so once you move on from just x's being squared, it makes these problems just a little bit tougher. Okay. So for example, you notice that it's b to the fourth, you notice it's 16, you notice it's two terms, minus in the middle. So chances are this goes by difference of squares. Okay. So you have to sit there and ask yourself, all right, I know it's going to be two parentheses, two sets of parentheses. I know it's going to be 1 plus, 1 minus. Okay. And I know that 4 times 4 on the end is going to give me that negative 16. Right? Okay, so that's all good. All right, but what about b to the fourth?
It would be b squared.
And b squared and b squared. Good. Because b squared times b squared gives you b to the fourth. Okay. Now, what other way could you change the exponents to give you b to the fourth? Not just 2 and 2, but Federico?
I put like a B on the outside and a B on the inside on both of the equations.
Can't do that. All right, because then you had to distribute them back in, and then when you distribute them back in, you'd have extra b's. Okay. Your other way you could write these is 1 and 3, right? Right. That times that gives you b to the fourth too. But then think about the rest of your FOILs. It'll also give you b to the third term and b to the first term in there someplace. Okay. So the only way this works is b squared. All right. So 625 minus x to the fourth. What's being squared on 625? Anybody know?
25.
25. Good. Your calculator. It ends in a 5, so take a guess. Okay. But same way. Same style. Same. I call them blueprints, right? With your factoring stuff. You know, you follow your grouping blueprint, you follow your difference of squares blueprint, stuff like that. Okay, Patrick?
Does it matter which order the plus minus goes?
No. As long as one binomial is plus, one binomial is minus, doesn't matter which one goes first. I typically put minus first. You can see I put plus first on this one, but usually I do minus first. It doesn't matter though. Other questions? Hey, there's your 4. Have at it. 3, 2, and 1. Y squared minus 1, y squared plus 1. 2a squared minus b squared, 2a squared plus b squared. 9 minus x squared, 9 plus x squared. 4y squared minus 1, 4y squared plus 1. Clayton.
Does it matter what order the negative and plus?
For the third time, no. Everybody good? Anybody bored? Good. Let's kick it up then.
Hey, dang. Oh, it might be that bad.
It looks innocent enough, doesn't it? I mean, that looks easy enough, doesn't it? I mean, it's 2 terms.
No. It's the only thing that's tripping me up is this 5.
This 5? Yeah, that 5 throwing you off? And the 45. And the x to the 5th. And the minus. And that x. The whole thing's messing me up. False. Padge.
Maybe you break it all down by, if it has like the same number in it, then you break it all down by one number.
Yeah, first thing you always do is a what? How though? Starts with a G. GCF. First thing you always do. Always look for a GCF first. Always. 5. 5 what? 5x. Ooh, that's an idea. 5x. Okay? And that's a very important idea. So we take a 5x out. Which leaves us with what? X to the 4th minus 9. And then what? Good. 5x. X to the second minus 3. X to the second plus 3. It's a twofer. Okay, it's a twofer. What's the first thing you see? Hopefully. Everything's divisible by 7, so let's go ahead and take that out, right? So 7, parentheses, x cubed plus 3x squared minus x minus 3. That's great. Energizer Bunny.
Keep going.
Keep going. What goes next? Split them up because we are going to do what? Starts with a G. Group. We're going to do grouping. Now this is where this gets just a little nasty. Okay, just be careful. Right for parentheses. All right. So 7 on the outside. Parentheses. GCF out of x cubed and 3x squared. X squared. Leaving you with? What do you take out of this guy to make it an x plus 3? -1. To give you x plus 3. Close parenthesis on that binomial. Close parenthesis on that whole grouping. Grouping. Right here. See, 4 terms. So you group it.
Oh, okay.
Binomial's got to be the same, right? I know it's been a couple weeks, but you got to remember. You take the x plus 3's out. There they are. You're left with x squared minus 1. Minor.
7 parentheses x plus 3 parentheses x plus 1 close parentheses x minus 1.
Atta girl. Energize the bunny. Keep on going.
I got that, but then I just stopped there.
Keep on going. 7. X plus 3. X plus 1. X minus 1. That is your final answer. That is that guy completely factored. Okay.
I didn't do that last part. I stopped it.
I said that.
Minus.
For my second answer.
No, you didn't. Patch.
If it's not x squared, then we got the x plus 3.
Say what? Do what now? Alright, 2y to the 4th minus 50. Take out a 2. Leaves you with y to the 4th minus 25. And then that goes to y squared minus 5. Y squared plus 5. Go as far as you can. Alright? Alright, 6x to the 4th minus 96. What should you take out first? A 6. Which leaves you with x to the 4th minus what?
16.
16. Very good. Okay, which gives you 6. Okay. Bunny.
Oh, it could be 3x to the second minus 2 and x to the second plus 2.
Not x to the second.
X.
X. Just x. See right here? Difference of squares again. See that? 4 is 2 and 2. Okay? You gotta watch. 6. X minus 2. X plus 2. X squared plus 4. That's one of your more difficult ones right there. Okay. Right there. That's one of your more difficult ones. All right, last two. First one, take out. I don't think there's GCF throughout. Doesn't look like it. So start with your grouping. So take out an x squared, leaving you with 2x plus 1. Then take out a minus 25 to give you a 2x plus 1. 2x plus 1, x squared minus 25 to give you 2x plus 1, x minus 5, x plus 5. So grouping, taking one more step. And the last one, once again, no GCF throughout, so you just go y squared, give you y plus 6, plus 11, to give you y plus 6. And then you get a y plus 6, y squared plus 11. Anything else?
No.
No, that's it. Okay? And they do that. They will throw, the book even does. These came straight from the book, Guided Practice, page 517. They'll do it to you. And that's the textbook. It doesn't even have feelings. And they'll do that to you. Imagine what me, a cold-hearted teacher, will do to you. So be ready for it. Be paying attention, okay? Because it will mix in. Ones that can keep going, ones that can't. All right? Make sense? It's all stuff besides, I mean, the difference of squares is new, obviously, but it's pretty simple. But that's only half of this lesson. The other half is mixing it in with other types of factoring, all right? Questions up here, people? Everybody good? Okay. All right, 518, 1 through 12, and 44. People, sorry to run you up to the bell, but have a great day.